Ladies and gentlemen, welcome to the study of QM, that is quantitative methods. I'm very fine and I hope I find you well too. In today's discussion, we'll be focusing on simple interest and compound interest. In case you still need some areas clarified after this discussion, you are welcome to do so. The numbers are as shown on the slide with a 666 at the end. Well, we are going to be focusing on the concept of time value of money. Then we look at simple interest. Then we conclude by looking at compound interest. Well, they say $1 today is better than $1 tomorrow. Or some say a bird in hand is better than a bird in the bush. What do we mean? It means it's better to have the money today than to have your money tomorrow. We'll look into that. Why do we need money today? For obvious reasons. We have got inflation. The erosive power of inflation, we know it very well. In 2007, a taxi ride, the taxi fare was $7, but today how much is it? We're talking of $10. But the distance that you'll be traveling is the same, but you're now paying more. Why? Because money, we say, is losing value due to inflation. Inflation being the general escalation in the prices of goods and services. Well, this whole idea about the loss of the purchasing power of currencies is what has resulted in people wanting to compensate for the loss or reduction in the value of money through charging of interest. We have got two types of interest. We have got what we call simple interest, which is basically the total interest that you are charged on an amount of money that you would have borrowed or invested in a bank. Then we've got compound interest. In compound interest, this is a special interest where the interest that you have earned with the passage in time, it will also earn interest. And the term that we must also know at this stage or juncture is principal. Principal is the original amount that you either deposit or you invest elsewhere and expect it to yield some return in the form of interest in the future. Well, on this slide you can see the formula. That is the formula for the calculation of simple interest. The principal, we multiply it by the interest rate. Usually it's a percentage. Then we multiply by time period. Usually the R, which is the interest rate, it's expressed as a percentage per annum. Then when we multiply the principal multiplied by the interest rate, then times the number of periods or years, then it will give you the total interest earned. If you have invested $1 and you are, let me illustrate that by, there is an example here that I might use. $1,000 invested at 7% interest rate. The $1,000 is the principal, the original amount. The rate is 7%. See, 7% is the same as 0.07. If we multiply the principal times the interest rate, okay? And assuming the time period is 5 years here, which is given, we multiply by 5, we'll get $350. Now, so this is the total interest that we will earn on the original amount, which is what? 1,000 over a period of what? 5 years. Assuming every year the amount is getting an interest return of 7%. Right. So this being the case, we are saying the amount that we invested, 1,000 that we invested in year one, it was earning 7%, which is 0.07 per year. Then we multiply by the number of years, 5 years. And what we get? We get the 350 shown on the slide. That's simple. That's why they call it simple interest. Why? Because it is indeed simple to calculate. Right. Now, if we now after having calculated the interest, we got in our previous slide, remember, we got 350. That 350 is the interest. So suppose we add that interest to the principal. The principal plus the interest earned equals to the worth of the investment. So when you invest, you are looking at how much money it will be at the end of the day. That's what we are interested in. Okay. Now, let's say we do exactly that, right? That's what we will get. After 5 years, our amount will go to 1,350. So, an investment made today for the next 5 years, earning an interest of 7% is worth 1,350. In business now, when we are making an investment, we are looking at the value at the end of the time period of the investment. We don't look at the 1,000. We look at how much are we going to get after the period of investment. In this case, 1,350. It is the amount that attracts us. Now, let me move to compound interest. What do we mean by compound interest? I've said compound interest is an investment where interest earns interest. Sounds funny, eh? Interest is earned. And from that interest, we also earn interest. So we are earning interest on interest. Okay, nice one. Okay, let's look at how we go about the calculation of compound interest. A nice formula. P, which stands for principal, multiplied by opening bracket 1 plus R to the power N equals to A. A is the amount of the investment, the worth amount of the investment, what we'll get at the end of the day. Well, N stands for time periods. Most of the time, people mix this with years. A period is the time the investment or the interest is calculated. It does not represent the number of years. So, if we invest our amount for 1 year, I think let me do some illustration there. What we mean is, suppose we have got the 7% interest. I will bring again the same example of $1,000. Okay, that's the P, the principal. The interest R is equals to, let's maintain the 0.07, which is the same as what? 7%. Okay. Now, time period T, right? Okay, I'll call it, it's given as NE. I'll just say it's what? A year, 1 year. What does this mean? It means this amount, we are calculating our interest once per year, right? So our N, it's 1. In this case, N is equivalent to a year. But we don't look at it as a year, we look at it as a period, 1 period, because we are calculating it once. If we are calculating this interest every month end, then our N will not be equal to 1, although it's 1 year. It will be equal to what? 12. Suppose we were calculating the interest twice a year. Our N will not be 1. It will be 2, because it's the time, the number of times we are calculating the interest. That's what is represented by time periods there. Okay. Let's go back to our example. I hope you can see it there. All right. 1,000 invested at 7% interest rate compounded yearly for 5 years. Okay? It will be 1,000 multiplied by opening bracket. Remember our formula there, right? It's the 1 from the formula. It's that one. The R is the rate of interest, which is 7%, which is 0.07. It's this one. Okay? To the power 5. N is 5. What it means is interest is being calculated once per year at the end of the year. So if it's 5 years, it will translate to what? 5 periods. And what does that mean? We have our 5. Now, what we'll end up with here is, if we are to deal, brackets, remember body mass, right? This part we deal with this one first. It will be 1.07 to the power 5, okay? All this multiplied by what? By 1,000, right? If you calculate this, you will get, your answer will be 1,403. That is the worth of this investment. If you deposit your amount in a bank account that yields an interest rate of 7% per annum, and you invest it for a period of 5 years, it means this 1,000 will grow to 1,403. That is after how long? After 5 years. And I would like to believe that we are all conversant with the way we calculate the power. Okay? I know sometimes we sometimes have problems. Let me just illustrate one or two things, okay, that you do there, right? Let's say you're using a Casio, a calculator. I just picked on that one. It's simple. On your calculator, you just what? Punch the 1,000. Punch the 1,000. Okay? Then you punch your multiplication sign. Then you punch those numbers in the brackets. Okay? 1 plus 0.07, which is simply 1.07. 1.07. Okay? Then what do? To the power, I'm only interested in the power. If you're using a Casio, when you get here, after this bracket, remember that sign. That is what you use for your power. Then once you do that, right, you say equals, you get that answer. But to somebody who is using what? A sharp calculator, here, there is a difference here. Instead of punching, right, because after this, you punch the 5. Then it will give you the equal sign, right, with a Casio. But with a sharp calculator, I want you to take note of this part. You don't have this. You just look for that button which is like, which has got a y to the power x. You punch that one, right? Then after that, you now punch the 5 and the equals. It will give you that one. Be careful, because a lot of guys, a lot of students always face problems when it comes to calculating that part. Right. Here is an example of how we can calculate it as well. Right. Let us say you want to calculate compound interest here where we've got multiple investments. So what we just do, we multiply by, we look at the payment, okay, either that we are making or that we are receiving. It may be a receipt, okay. We want to find the compound interest, the value of it. The payment that we are making, here we're assuming this year you pay, for example, you deposit in the bank 1,000. Next year you invest 1,200, and the amount is not the same. It's changing. Okay. So when it's like that, you simply say each payment. Now you look at the payment, then you multiply. Let me give an example. We have got an investment of this nature. Let me say it's year 1, year 2 there. And let me take only those ones. In year 1, we make an investment of $100. In year 2, we make an investment of 150. And what is happening here is we are compounding these amounts at a rate of 7% per annum. How much would this be? What we'll do, here is a simple example. At the end, and we're investing it for 2 years, okay? And we are doing these calculations at the end of the year. What do we mean? If you look at this $100, right? At the end of year 1, okay? The principal will be 100 multiplied by 1 plus 1.07, isn't it? At the end of year 1, which will give us an amount of 107. That's what we're saying here. But this 107, it's going to be invested again. When it's invested and we're investing at the beginning of year 2, right? From here. So we'll start January of year 2 with $107. Then we calculate interest again at the end of year 2. It is 107. We multiply it again by 1.07. Okay? To the power, we don't have to, it's to the power 1 because it's only for 1 year. So when we do that again, we are calculating 7% of 107. I would like to believe we'll get something in the region of 116 thereabout. It's not correct. I just thumb-sucked the figure there, but I know it's going to be more than 7%. Therefore, I added an 8 to make it 106. I guess I'm correct. So that's what we do. And the same amount, this 100,000, we could have simply multiplied it as follows: 100 multiplied by 1.07 for 2 years to the power 2. You would find that if you had done this, we would have gotten a figure of 116 thereabout. That's what we are simply saying here. Okay, now this 150 has been invested for what? For 1 year. If it has been invested for 1 year, it means the 150 will need to also be calculated separately before being added. What it would mean is we would say 150 in year 2, it's only invested for that year 2, January to December. So we simply multiply this one by 1.07, which is to the power 1 because it's just for 1 year. And what will this give us? This will give us simple mathematics here. That 100 by 107, we know very well that the interest will be what? Will be $7. The 50, therefore, for that particular year, it will be half of 7, 3.5. So our answer here will be $110.50. This will be that amount. Now, if this is the investment, what we'll get, right? Now, if we go back to our investment of saying we've got year 1 and year 2, okay? This 150 invested in year 2, we have said it will translate to 110 to the power 0.50 cents. And this one will translate to the $100 here invested for 2 years, okay? It will translate to that figure that we got of 116 approximately. Then our total investment will be this plus this, which will be 100, do this, write it down, it will be 226.50 cents. This is how we calculate our compound interest. In our example, the example that is on the slide there, if you critically look at it, we are saying payment. Sometimes we've got situations where the amount that you are investing in the bank or making a payment, it will be more or less like an installment. It's the same amount every year. Now, what you simply do is you simply say payment multiplied by 1 plus interest rate over time period divided by R. And this, what we've just done, what you are seeing there, let me take this one and put it to the slide. Suppose we've got a situation where we are paying the same amount every year. That amount that we are paying every year is what is represented by this amount, right? So let's say in this example you are given this 1,000, which 1,000 is being invested every year at a rate of 7% per annum, okay? And we are investing that amount for 5 years. We just take the same formula, right? That is given here. Slight change here. You see, It's now minus 1 over R. And this R and this R is the same thing. So what does that mean? R is 0.07. That's why you see we've got our 0.7 here. And R, the denominator, is the same amount. We have also taken it below there. Then N does not change. It's the 5 years that you can see in the problem there. 1,000 invested every year at 7% annual rate for 5 years. We put, but we now have minus 1. Okay? So when we do that, it's a question of what? Substitution. 1,000 multiplied by this, it will give us 5,757. This is how we calculate compound interest. And it goes on and on. It does not change. So basically, when we look or try to compare compound interest and simple interest, you would find that one of them, especially if you are investing, one of them is most preferable. Which of the two? If you are depositing money in a bank, then you would find that the simple interest does not give you more money than the compound interest, although the rate may be the same. If we're using 7%, in the first example, you remember, we got 1,350, but in the second example, our compound interest yielded 1,403. What does that tell us? It means if you are the one who is making the investment, you would prefer a financial institution that will turn or spin or give you interest on a regular basis. Why? The advantages of compound interest are that you are earning interest on the interest, on top of the interest that you earned the previous year. Unlike simple interest, you just wait until the end of the year and you only calculate interest based on the given interest rate, and that's that. So, under those circumstances, if you look again, let's say you are the one who is what? Who is receiving the amount, isn't it? If you are receiving the amount, it's the same thing. You need to go for compound interest because you will receive more money than if you give somebody money and you charge the person simple interest. Well, I hope with these few remarks you have managed to grasp the concept of simple interest and compound interest. Further clarification, don't hesitate to get in touch with me. Until next time, ciao, ciao.